Hello and welcome to GOTO Book Club. Today we're introducing an excellent book written by Mr. Dennis Hansen called Model-Based System Engineering and Requirements Definition, Achieving a Uniform Management and Engineering System View. I'm Jorge Orellana. I'm an experienced enterprise architect with several years of working federal projects in national security space. And at this point in time, we would like to introduce Dennis and have a brief background from him.
Yeah, I'm Dennis Hansen. I wrote this book based on a very long career, starting out back in like 1960, working on a test program and some of the first automated equipment. The key point, though, is that like many factory owners where they want their son to work from the bottom up, that's kind of how my career went by happenstance. I started as a technician, working with engineers, went on to field sustainment, went from there to being commissioned and working in plans and programs for communications for Strategic Air Command. Then on to a satellite program where we designed our own equipment for the ground system, from there to acquisition. So that covers user end of things. And then from there, I went on to, that was a 21-year affair. I then went on to 40 years at Harris Corporation, now L3 Harris, as the chief system engineer for several programs, including the complete redo of the GOSAR ground system for NOAA and NASA. So it's a very broad experience that allowed me to see things from different aspects. And that's what this book attempts to do, is to show things from multiple points of view.
Excellent, Dennis. And I truly enjoyed reading your book. It refined my understanding of model-based system engineering. And it also gave me, reinforced some of the things I already had in my mind, but maybe didn't write down why I do things in a certain way. Why do I do one model before another, and how to approach the work in general. That being said, I'd like to talk about how you structured the book next. And so I'll put one of your excellent figures in your book, figure 6.1, document development flow. And I think this helps understand how you structure the book in general.
Yeah, so the very first part of the book is the need for basically the end user and the acquisition agency to define the mission. And then from there to go on, what capabilities do I need to do the mission? And then you start working with either FFRDC like Aerospace Corporation or a subcontractor to work out the activities that go along with those capabilities. And keep in mind that you can move back and forth between activities and capabilities to where you're sure to have things properly worded. That's critical. Because from there on, as you start doing the activities, you're going to do your technical requirements document. In recent years, the government does not issue a specification. They issue a technical requirements document, a TRR. And from there, the prospective prime contractor would go on and write the specifications from there using the models. And then all the modeling goes into the system specification. And then from there, you go on to the subsystem specifications. And you're again moving from SysML type of viewpoint to a UML viewpoint. The behavioral aspect versus the go build it aspect.
Excellent, Dennis. Yeah, the book has a great structure, and it's operational, then detailed, and then system level views. That being said, I want to jump to another view that we could talk to. Well, this is another approach and model you use that I really love, the awning analogy of layered system definition. And you can share some background on how you use it and how you came up with this great model and approach.
Yeah, this is an approach that I was basically taught by a Motorola engineer in 1961, and I've used it ever since. The bottom line is, if you look at an onion and its layers, you can take the entire onion as this is the mission I'm trying to perform. And from there, you've got the capabilities that I mentioned before, the activities, etc. But what I've done here is highlight what kind of documentation goes in at each of those points. So you've got the model leading to the documentation, either a capabilities document or a technical requirements document or the end specs. And you finally wind up down at the detailed design, which is all your UML and your C, C++, whatever language work that you're doing with the system. So if you take it a piece at a time, it makes it easy to track what you're doing. I've had experience with programs where they start trying to do two things at once, like take two of those layers at once. And invariably, it winds up with an excess of requirements, or it winds up with faulty requirements, which is going to give you fits at the end when you do your system testing. And hopefully not ultimately your end user trying to use the system and finding the fault then.
Yeah, and it just dawned on me, like you see the elephant analogy, how you eat the elephant, and this kind of is another approach. I think a lot more detailed, so you can understand the minutiae or details you're trying to describe when you're doing modeling. So you mentioned the OV1, and I really like your approach to the OV1 high-level system overview. Is I traditionally see graphics with a little bit of text and more symbology, but your approach to the OV1 is much more detailed and applying true UML modeling. So if we can talk through this OV1, I would love it.
Yeah, I know what you mean relative to the OV1. You normally see almost a cartoon graphic, and that's great for explaining it to the to upper management as you're trying to get the program through. But this is the next step you can take them down, where it's basically broken out the pieces of the mission. The overall mission you see in the upper left-hand corner. You see your actors off the side and how they work with the system. But then you go into here's the major functions for the ground system example. You're going to provide system security, and that applies to the entire program. And that's why the connector is represented as a generalization. And then you're going to have to manage that ground system. You're going to have to plan your missions. You're going to have to, as a part of that, it's a good idea. I learned this through experience. Do a satellite simulations. And that means a satellite simulator, to where as you build your command loads and such, you can test them in advance on the ground before you try and send it to the satellite. Also, as a part of planning is you should have previously done some analysis of telemetry that you received earlier, which, as you see, is a part of perform command and telemetry. So now that's going to give you what your limitations are. What are your constraints on the mission that you're planning for? And then finally, you've got your payload data, whether it's, in my case, I worked with weather satellites quite a bit. But what the mission data is going to look like, whether it's soundings, imagery, etc. And you're going to do some pre-processing of it. And then ultimately, in this case, I show where you send it to the using organization, to where they can put a fine tuning on the images and other data for use by the meteorologists in this case.
Dennis, and that reminds me, so another value of this book is all the examples are consistent with the same thing you're describing. You based it on a specific system. So I think that's useful for the readers, so they get not only read the book and your insights from based on 40 years of experience, but they also get to review a working architecture that's complete and comprehensive and consistent. So they learn to understand, high level detail to low level detail all in your book.
Right. One of the faults I find with a lot of books, and it's not meant as a bad thing, but a lot of books go and take pieces of MBSE and they look at one very small example, but very seldom do they talk about how they relate. So this this approach of taking an actual system or a possible system and taking it step by step shows how it all relates. And a key point is this book is written at a level such that it's of use to the engineers, but also of use to managers. I incorporate a guide for managers and engineers at the beginning of each chapter to where managers who get very bored with the technical details, as I've found, can skim through and see what work is really needed and why do we need to do it. And that's extremely important when you go to the program planning and the program execution, and avoids those cases where you try and do two things at once.
Check. So Dennis, we'll jump to another model. And again, you're trying to take the reader to the high level detail to more low level detail. And I picked this model so we could talk through the detail under the hood that you describe in your book and also showing these examples.
Right. This particular detail is showing where we've taken at a SysML viewpoint the major operations. So again, we've got the managed system, the managed security, et cetera, through here. That starts breaking out some additional detail. You can see the messages as they flow. You'll notice within the book, I've got notice of pushing off to another diagram because of the book size, physical. Obviously can't put the entire diagram on one page. So these are like connectors to other pages. So that you can take it and move like it was one big diagram, but you're not trying to fit everything on one single page. I think if you've been in the business very long, you've seen someone that has almost a wall-size SysML diagram, and it's actually harder to file than having pieces that you can stitch together with connectors.
Yeah, this diagram highlights another, use for the architecture, which I love to get these questions as a architect is, do we know if our system is compliant to NIST standard? You put NIST SB 800-53. And I could say, well, I don't know, but let me check the diagram and run a report. And yep, you are. And this is where we're applying it. And I could show you right here. So it could easily answer a compliance report, a one-off that might come from DoD CIO or whoever.
Right.
It's hard to manage this complexity and no one knows everything about your system, but that's why the architecture, the modeling helps.
Right. And I think the big point is that I try and push is take the security features. 800-53 covers things almost from a administrative viewpoint, but you can design in at various points the features that help to administer that. What I'm trying to avoid is the problems that I've seen on programs where you get down to accreditation and you wind up with a long list of what they call POAMs. These are the corrections you have to make before they'll sign off on operation. So that's what this does, is allow you to start it up front, be able to prove where it's handled, and be able to get it signed off in the end without any real problems.
Copy. Okay, one last diagram to show. And again, this is just to whet the reader's appetite, what the appetite for the reader to go out and buy your book, and they'll learn how to do this modeling based on your 40 years of experience, Dennis. So again, this is a figure C-2
right.
login activity diagram. So yeah, it shows an activity diagram to talk through, which gets into flow dynamics.
Right. It starts with trying to do the login, but you notice right in the center there is where I start handling how to deal the login from the 800-53 standard. And you'll notice that this is the little fork there that shows this is a behavior call, and it goes off and links to other diagrams, which is I mentioned the word link because it's very important. The modeling tools are not drawing tools. They're a database. And if you properly use it and link these elements to the various levels, it provides you with a way of tracking how the system's functioning, keeping it together. It's going to keep you from missing things. It in general has some great benefits. And the other part is each of the elements that you see here and in the sublayers has the requirements necessary documented with each element within the tool, as well as notes as to what was your thinking when you came up with this approach on the design. And that part is real important because we all take holidays, we have weekends, other things happen to take you away, and you go back to your modeling and say, now, why did I do that? Well, if you've got it in the model written down, it provides you a starting point and avoids a couple of hours of trying to figure out where was I.
Excellent. Right. It's an excellent tool to remember. And why do we do this modeling? Because it's complicated and no one person understands the system in detail like you should. And that's why you do the modeling. It really is a tool. So that's the last figure I want to show and, get into a few general questions. So one of the things I really loved and was happy to read was I think you're like-minded that, you don't do modeling for shelfware. You do it to learn, you do it to understand. It's iterative. You go back to it and you refine it. If you could talk a little bit about the value of doing that based on your experience, Dennis.
Well, the value basically is you avoid all the problems in the end. The structure of the book is such that I recognize the fact that government people like to use DODAF, for example, as a tool. I don't mandate DODAF all the way through. I actually provide a point where you can switch off right around the system views to your SysML. And that recognizes that the engineers have been trained in using the SML, so you don't want to have them go backwards and try and learn something else. And then when the SysML is done, ultimately, because it's based on UML, you can migrate to the UML views for the software people. So it provides a flow of based on how people have been educated, what is their background, how can I flow through the system and through the model and yet maintain its consistency and the requirements necessary to implement the system. So now you've created the documents that are required by Seadrill, you've required your model views, you've got consistency through the whole system design, which ultimately, in the end, there is one point that I bring out in the book at the end, and that's sustainment. If the using agency maintains the model, keeps the model on hand with someone who knows how to use it, and something comes up where you need to make a change, you want to make a change to how you operate, you can chase backward through the model to find out what's affected. What points have to be modified to add this so that you don't just immediately put a tack on application and try and do something and find out where you've created a large number of errors along the way, which we've all experienced the miracle one line of code cure for the situation, which created 5 new problems. So that's what this is attempting to do. Plus, once again, it's written such that the managers of the program and the executives who are overseeing it can have a view of what's really being done and why you need to take the time to do it right. But if you do it right up front, spend the necessary time, it's going to go smoother at the end.
Excellent. And I think my last question for you, Dennis, and again, want to benefit from your over 40 years of experience and remembering back when you were green and new, how do you get started with a complicated effort, especially when, the government clients kind of feel like the work is forced upon them. They need to do these models. They need to do this architecture. How do you get the conversation going? Is it just start and draw an OV1? How do you do it?
What I start out with is I draw kind of the mission and what are the pieces that go along to trying to do it. And I use that to generate potential requirements or descriptions. And I keep working it down to where I can come up with my first view, like even the OV1, the OV2. These are what the government would use. And it starts to define what interchanges are necessary? What message and control flows are going between these pieces? So it really helps to keep it. Every piece that you do new is based on something else that came before it. And now you're going to maintain to where you don't have outlandish requirements or functions that actually get in your way later on. I think many of us who have been in the business a while have run across that case in final acceptance testing. I actually had one program where they were trying to make requirements changes during acceptance test. The old, we're doing this function. I really should be able to do this, this, and this. And they were holding up the contract sign off to add things to the contract. So it's a good source of what we call cost overrun. We've seen it in the newspaper plenty of times, but that's part of it. You didn't define it properly up front, and it caused the problem in the end.
Copy. Well, I think at this time we could wrap up our preview to your excellent book. Again, thank you so much for writing it. I took so much out of it, learned some new things. I really appreciate your time sharing it and talking through it with me. Any final thoughts, Dennis, before we wrap it up?
No real thoughts other than please use an organized process when you do your definition of a program and your carrying out of the program. And one point I make throughout the book is collaboration. Systems engineers don't sit by themselves. Software engineers don't sit by themselves. Security engineers don't sit by themselves. At each stage, as you move on, have a team meeting, get together, collaborate, and make sure that all parties are aware of what you did and why, what each party did and why. And that saves a lot of problems in the end.
Excellent, Dennis. Well, thank you again.
Thank you.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.